Hi everyone, this is practice formative of chapter 3, integration, topic 3.1, integration as the inverse of differentiation. Now let's look at question 1a. So we are given a differentiation of this expression, x cubed plus 12x squared minus 3x equals to 3x squared plus 24x minus 3. So we have to find the integration. So the integration is the inverse function of differentiation. So the moment we bring the differentiation notation across to the other side of the equation, the differentiation will now be inverse. So x cubed plus 12x squared minus 3x, the symbol come to the other side will turn to be integration. So integration of 3x squared plus 24x minus 3 dx. Isn't it? This is the question. All right, this is the question that we need to find the answer. So the answer is x cubed plus 12x squared minus 3x. That's it. So for part B, we after differentiate this, we get 12x cubed plus 2x. So if I change the differentiation function across to the other side, we can rewrite it in integration of 12x cubed plus 2x dx, isn't it? Therefore, this one, the answer will be, so let's write this one, x cubed plus 2x dx. We will get back the original expression, that is 3x to the power of 4 plus x squared plus 7. That's it for question number 1. Now, let us move on to question number 2. Now, for question number 2, part A, given that the differentiation of 4x minus 5x squared plus 2x cubed equals to this, so we need to find the integration. So same thing, since the information given is in terms of differentiation, but the question asks about integration. So let's change the question from differentiation to integration, which means once I bring this across to the other side of the equation, I will have integrate 4 minus 10x plus 6x squared with respect to x. We will get back 4x minus 5x squared plus 2x cubed. However, the question asked is 2 minus 5x plus 3x squared. So if I factorize the 2, okay, from this expression, so we will get 2 integrate 2 minus 5x plus 3x squared dx, isn't it? This will be the question asked. Therefore, we can copy this one first, minus 5x squared plus 2x cubed. Therefore, to find this, 2 minus 5x plus 3x squared dx, we just need to bring the 2 to the other side, which means we divide the whole thing by 2. So we will have 2x minus 5 over 2x squared plus x cubed. This is the answer for question number 2a. Next, given that in differentiation of this equals to that, so we need to find this one. So let's rewrite this to the other side first. We will have integration of 2 plus 12 x to the power of 5 with respect to x equals to 2x minus 3 over x to the power of 4. Now let's compare the question and the expression that we just formed. So over here, in order for us to get back the 6, okay, as given in the question, we need to multiply 3. So let's multiply 3 here. So when I multiply 3 to this equation on both sides, yeah, we have to multiply on both sides. So 2 plus 12 x to the power of 5 dx. So this side we also multiply 3, 2x minus 3 x to the power of 4. Isn't it? This one is, so continue from here. Isn't it? We will get 6 plus 36 x to the power of 5 dx. Okay, the left side, isn't it? We get the same as the question given. And therefore, the answer will be multiply the 3 into the expression. So we have 6x minus 9 over x to the power of 4. Okay, that's it. This is the answer for 2b. Now, let us move on to 2c. Okay, so it is given that fx equals to differentiation of function gx. So we need to find this. Okay, we change this differentiation notation across to the other side. It becomes the integration of fx. Therefore, with respect to x, so we get gx. And let's look at the question. Okay, the question wants us to find integration of 2fx, which means we multiply 2 on both sides of the equation that we just formed. So we have 2 integration of fx dx equivalent to 2 gx. That's it. That's the answer. Okay, the 2b inside or outside, it doesn't affect the answer. Okay, so in part D, we have to first differentiate this expression towards the x first. All right, now let's find out that. So we're going to differentiate 2x squared over 3x minus 1. So we can apply the quotient rule. So this is u, this is v. So stay v, do u. Okay, the formula is v differentiate u, and then minus u differentiate the v, and then over the v squared. Okay, so stay v, do u. So we have 4x minus stay u, do v, which is 3, and then over 3x minus 1 squared. And open up the bracket. So we have 12x squared minus 4x minus 6x squared over 3x minus 1 squared. So simplify the numerator. 12x squared minus 6x squared. So we have 6x squared minus 4x over 3x minus 1 squared. So this is the differentiated expression. And next, we have to find the integration of this. Okay, so from the information given, we have the differentiation equation, but we have to use the integration. So, which means, let's do like this. Okay, which means if I reverse, I bring this to the other side. So it means when I integrate 6x squared minus 4x over 3x minus 1 squared, I will get back 2x squared over 3x minus 1. Now, so let's compare this with the question given. The question is 6x and then 3x. So let's bring in, okay? So let's bring in, open up the bracket. We have 18x squared minus 12x over 3x minus 1 squared with respect to x. Now, let's find this part in the question. So how do I get back 6x squared? So I factor the 3 out. So take out the 3. I have left with 6x squared minus 4x over 3x minus 1 squared dx. Isn't it? This is exactly the one that we just written. Therefore, only this part we replace with the integrated answer, which is 2x squared over 3x minus 1. Okay, the whole thing multiplied with the 3. So our final answer will be 6x squared. 6x squared over 3x minus 1. Okay, so that's it. We found the answer for question number 2.